Hello, I'm Papia, and today we will see an application of Rolle's theorem. We have this function f of x is equal to x times square root of x plus 4. First, we have to find two x-intercepts of the function. So let's do that first. How do we compute x-intercepts? Well, we set y is equal to 0, and y is the function itself. So let's set fx equals 0, and the function is x times square root of x plus 4. That is equal to 0, and we have to solve for x. Now, look, there are two factors, x and square root x plus 4. So the product will be 0 if each factor is 0. So from here, we get either x is 0 or square root of x plus 4 is 0. Notice that we already have one x-intercept right here. We can find the other one from this equation. So when is square root x plus 4 0? You can square both sides, and this will be x plus 4 is equal to 0, which means x is equal to negative 4. So we have our two x-intercepts, x equals 0 and x equals negative 4. All right. For the second part of this problem, we have to show that the derivative of this function will be 0 at some point between the two x-intercepts, and those are negative 4 to 0. Now recall the hypothesis for Rolle's theorem. What does Rolle's theorem say? It says if our function is continuous, differentiable, and we find 2 points, 2 x values where the function value will be equal, then we have some conclusion. And the conclusion is exactly what we have to show, actually. So let's look at this function and see if it satisfies those hypotheses for Rolle's theorem. Now, you have to be careful. Look at the domain of the function first. Is the domain everything? Well, it has a factor x, which gives us that the domain of that portion is everything. You can plug any x and it's fine. But the second part, there's a square root. And so you have to be careful. We cannot plug in any x value that will make this expression negative. So if you notice that the domain is all those x values so that x plus 4 is positive or 0, right? So the domain is x greater equal to negative 4. Now notice, in this domain, this function is very nicely defined. Any x value you plug in that's greater than or equal to negative 4, the function is going to be continuous. So we can say that f is continuous in its domain. But notice, we are applying Rolle's theorem only in a restricted interval. And the interval is between the two x-intercepts, which we found right here. So we only consider the interval from negative 4 to 0. So we just explained that the function is continuous everywhere in its domain. So for x greater or equal to negative 4. So obviously, it will be continuous in a restricted interval inside its domain. All right. Next, is the function differentiable? If you notice, it is going to be differentiable everywhere for x greater than negative 4. And so that is the second hypothesis for Rolle's theorem, that f is differentiable inside the interval. We don't need to include the endpoints. Third condition is that the function values has to be equal at the endpoints. So let's see, what is f of negative 4? Well, you can go back to the expression, plug in negative 4, positive 4, this is 0, so the entire thing is 0. But also notice that's exactly what we found here, right? The x-intercepts are negative 4 and 0. So of course the function is 0 at negative 4, and same thing happens if you plug in x equals 0. So that means f of negative 4 is equal to f of 0. So at the endpoints, function values are equal. So these three things satisfies the three hypotheses for Rolle's theorem. So what is the conclusion? So we can apply Rolle's theorem to say that there exist at least one value, one c, inside the interval from negative 4 to 0, where the derivative of the function is going to be 0. And that is what we have to show. So we just showed that using Rolle's theorem. Now let's see if we can actually find that point. Okay, what is that x where the derivative will be 0? For that, we need to compute the derivative of the function. Okay, so look, here is our function. So let's compute f prime of x. Notice this is the product of two functions, x and square root x plus 4. So you have to apply the product rule. So keep the first function as it is, keep x as it is, and take the derivative of the square root x plus 4, and let's write it as x plus 4 to the power 1/2. This is product rule, so you add and then you keep the second function as it is and take the derivative of the first one. Let's see. This one, x plus 4 to the 1/2, you have to apply power rule and chain rule. Outer function is the power 1/2. So you apply power rule first. So you will have 1/2 x plus 4 to the power 1/2 minus 1, so negative 1/2. Then you go to the inside function, x plus 4, and its derivative is just 1. Okay, for the second term, derivative of x is just 1, so you will just end up having square root of x plus 4. Remember, we have to figure out for which x is f prime of x equals to 0. So this is our expression for f prime. So let's try to combine them and simplify and then set it equal to 0. Okay. So here, for the first term, x is in the numerator. Denominator will have 2, and then x plus 4 has a negative exponent, so bring it to the denominator as positive exponent. So it will be 2 times square root x plus 4. And the second term is just square root of x plus 4. Now you can add them together as using common denominator. So common denominator is 2 times square root x plus 4. And then it's just cross multiplying. Here the denominator is 1. So to get the numerator, you just multiply x times 1 plus 2 square root x plus 4 times square root x plus 4. So it will be 2 times just x plus 4. So note that in the numerator, we have x plus 2x. So that's 3x, and then plus 2 times 4 plus 8, divided by 2 square root x plus 4. So this is the expression for the derivative of the function. We have to figure out what is that x where this expression is equal to 0. So when is f prime of x equals 0? Notice it will be 0 only if the numerator is 0, right? So we want 3x plus 8 to be equal to 0. Therefore, x is negative 8/3. Notice, not only we know using Rolle's theorem that we will find some x inside the interval negative 4 to 0 where the derivative is equal to 0, but we actually figured out which x value it is. Note that negative 8/3 is an x value inside this interval from negative 4 to 0. This completes the problem. Thank you.